Testing, 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 testing. Sorry, folks, just setting my audio up. Check, check, check. Okay, that looks like it's good. I'm just setting up a new computer, so apologies for the delay. I'm still getting everything kind of worked out with the streaming details, so 1 second. Okay. That'll do. Okay, if somebody's in the Slack thread, can you give me a thumbs up if you can hear me and see me, if the audio is coming through and the bit rate is decent? Just let me know how, if the streaming quality like needs to be changed or something. Oops. Give me a thumbs up in the Slack thread if everything's good. I know there's a little bit of a delay, so we'll just wait for that. Okay, cool. Looks like we got a thumbs up. All right, thank you. Let's get started then. Yeah, again, apologies for the delay. A little bit of a new look here. I've got a brand new computer, fresh out of the box. I'm running Linux again, which I'm really excited about. So I'm hoping the streaming quality is going to be better in general. There's a humming sound in the background. Oh no. Let's see. Did it go away when I did that? I turned my fan off there. I'd have to address that humming sound in a different way. Okay. Might have to get some of the audio issues worked out over time, but all right. Let's see. So yeah, let's just jump into it. Video's a little blurry. Might just be me. Can anybody else confirm whether the video is a little blurry for them as well? It's a little low res. Let me see if I can change. Oh shoot, I might need to change that. In the stream settings. Okay. Cool. I'm going to assume things are good enough at least to continue. Do let me know if there's issues. You know, the point where like it's too choppy or too low res to see anything. It looks like there's people adding clap hands to that. I'm taking that as yes, it's also blurry for you. I'm not quite sure how to interpret that. Okay. All right. Work stream. Okay. Let's see then. Maybe we do need to address this now. Oh, I see. Okay, I misunderstood that. Uh, the clap hands were just people saying hello. Okay. I'm going to assume that things are good enough for now, at least, to continue, but I am interested in any feedback that y'all have afterwards. Or, like I said, if it gets to the point where it's like unintelligible, then I might have to restart the stream with better streaming settings. Okay, cool. Let's get started then. So we left off on split. We talked a bit about this last few times. So I won't go into too much more depth about this. We'll just kind of treat this as a little bit of an overview. Get that situated there. Okay. So split is a very useful method. Blah, blah, blah. So split really is a very useful method. It's going to allow us to break apart a string based on some substring. So if we have, comma separated values, a lot of times you're dealing with CSV data in CSV format. CSV stands for comma separated values. You usually will bring that in either through some library that handles CSV data for you, or you can write your own way of handling it, because you'll usually bring in that CSV data as a string and you can break it apart with split, right? So there's a lot of different use cases for this, for breaking apart words and lists, or words in paragraphs, etc. Yeah, so it's worth knowing. Cool. So this is just a basic outline. I'm worried that this is possibly too small. Might be better. Cool. Yeah, so we have our string that we're going to split, then the split method, and then the delimiter, which is just the substring that we want to replace with, or that we want to act as the delimiter for each element in the list that split returns. Okay, so let's just get into the challenges here. So what will the result of this code be? X equals, this is a string, needs to be split. We'll print x dot split on I, max split 2. Okay, so max split is split's second argument, and it'll tell us the maximum number of times to split, right? So this is going to split on i's, but it's only going to do it twice. So it's going to split on this I and then this I, it looks like. So I'm thinking it's this one. So th, there'd be an I there. This is, it's done. Okay, I'm going to go with that third one there. We got a question here. At what point should we start bringing in CSV data to practice split and join and other string techniques? You can start playing around with CSV data now. Like if you're to the point where you're learning about split, we could do this. Why don't we do this right now? Just make a little CSV data right here. CSV string. Something like this, just you're basically making a list inside of a string, and then playing around with that. There's a challenge in the prior example that had like new lines in it, and some of these were floats, and you had to go through and square these and reconstruct a CSV string with all the numbers squared, right? So something like that, right? So you can just start playing around with CSV like this. Now this isn't like bringing it in from another file, but this is, you know, you're still effectively doing the same thing, right? To bring it in from another file would be kind of like file I/O stuff that we don't really cover and learn as much. Bringing in Excel sheets as CSV files. Okay, so yeah, specifically if you're talking about file I/O stuff, we don't cover that in Learn. I wouldn't discourage you from playing around with it. I think we kind of get into that. If you go into further studies, there's some stuff on pandas that I think we'll get into that some more. So you might check that out. Cool. Okay. All right, so on the variable x, use the split method with spaces as a delimiter. Assign the result to a variable called yourList. Okay, put your code here. YourList equals x dot split. And I think they just mean literally spaces like this. Okay, cool. Write a function called da da da. Oops. Oh, I don't have line wrap on. Let's see. See if I can turn line wrap on really quick. It's a fresh install of my editor here. I don't quite have everything set up. Yeah, so just bear with me. Soft wrap at preferred line length. Okay, looks like it's not going to wrap. That's okay. I'll have to figure that out later. So write a function called split on this. Oops. That takes a string called split me and second, it takes a letter called splitter. Split me and splitter. The function should return a list that is split on every occurrence of that letter. Okay. So I think all we're just going to do def split on this. Oops. Splitter. Oops. split me splitter. Okay. And we're just going to return split me dot split splitter like that. I think that's all we need to do. Okay. Maybe we have an edge case here. If the letter is not in the string, the function should return cannot split on that letter. Okay, so we just have this sort of little error message here. If splitter and split me, then we'll do this. Else we'll return cannot split on that letter. Cool. Looks like we got a couple questions here. The code is a little blurrier. Increase the viewing size into view zoom in on browser. Okay. Alright, I'm gonna just increase the text size here just a little bit. Maybe that'll help things. Right there. Let's try that. I do usually have the text blown up bigger in my streams, so that would make sense. Okay. Let's just try this. And let's just we'll just split on this doc string here. And we'll split on I. Oops, we'll split on literally the character I. Hello. Let's see if I can use this new keyboard. Okay. Okay, cool. Looks like that did it. And, oh, I already submitted it. All right, lower, upper, and capitalize. Okay. So these are three just case transforms. For strings, we can transform the case to lower, upper, or capitalize. Capitalize will capitalize the first letter in the string. If it can be capitalized. If there's a letter that comes after a period, it won't capitalize that. So it's not smart enough to like capitalize according to what we would consider grammatically correct. It's just gonna literally capitalize the first letter. Lower gives you the string back with all lowercase letters. Upper gives you the string back with all uppercase letters. And that's it. That's what these do. Of the three of these, we use lower a lot. I'll use lower to like ignore the case, essentially. There's also, I think there's a method literally called ignore case. Let's actually look at this really quick. Let's just start a Python 3 terminal, and I think it's, let's do dir of a string. Let's look at the directory for string. Swap case. Swap case is a really weird one. Makes the lowers uppers and uppers lowers. I'm not sure when that would ever be useful, but it's there. So let's see. Ignore. I can't remember what it is. Can't remember if it's called ignore case or Well, anyways, it's funny. There's a tool built in, a method built in for strings that's meant specifically for use when you're trying to like see if letters are the same without taking case into consideration. That's not dot lower, right? So there's an alternative to this, but I've never seen it used. I've always used dot lower. Everybody I know always uses dot lower for that purpose, and it just seems to be sort of the universal go-to. So, imagine imagine you were trying to do like a word frequency dictionary where you make a function that takes in a string that produces a dictionary where the keys are the words from the string. So you split the string into words, and the values are the counts of those words in that body of text that you pass to the function, right? So if you have like an uppercase this and a lowercase this, you and I would probably count those as the same word, but Python's not going to do that unless you standardize the case. So you might use something like dot lower, excuse me, to standardize the case. That way you can tell if two things that we would consider the same are the same. That way Python can tell that they're the same. Okay. So of these, I mean, just to be clear, right? Lower we use all the time for case standardization. You could use upper. You couldn't use capitalize. You could use upper or lower, although, like I said, it's like lower is kind of the standing convention, even though there's a tool that's different that's actually made for that. So yeah. And the other two, upper and lower, are just, just so you know that they're there. They don't come in handy quite as often. Cool. Let's just jump into the challenges for these. Okay. So what will the final value of x be after these operations? So I'm pretty sure capitalize will lowercase everything. But let's find out. I'm actually interested to see. Oh, oops, wrong terminal. Yeah, so let's just isolate this. So I look at this x dot upper, since this isn't being reassigned to x, it's just not doing anything. So I see a few reassignments of x, but the last one I see is dot capitalize. So even if this is the only one that's run, notice we have this mixed case string, and if I call dot capitalized, it uppercases the first character and lowercases all the rest. Like I said earlier, I was saying it's not going to capitalize anything like after a period. So if we put hello, if we put something after this, it's not going to capitalize that. See, we still get a lowercase hello. And then I wonder, I think it's not going to, I think it's just, yeah. If I put something that can't be capitalized as the first character in the string, it's just not going to capitalize it, and it's still going to lowercase everything else. So it's not going to capitalize the first thing it can capitalize. It's going to try and capitalize the first thing there, and if it can't, then it's just going to keep doing the rest of its job, which is to lowercase everything else. Whoops. So that'll be a capitalized string, which is it this one? Here. There we go. Okay. On On the variable string, use string methods to perform the following. Store the uppercase version of the string in a variable called upperster. Okay, let's do this. Oops. Yeah, we'll just have to do that. So this will be, let's see, do I even know my, there we go. This will be string dot upper lower capitalize. Yay, I did it. Okay. Wait, does this say 3 twice? Oh, okay. That's me. Okay, so write a function called string op. Let's take this one. I think I remember this one. Yeah, so this function is going to take a command as a string. And we'll run the appropriate. There we go. Make a few of these. Oops. Oops. Okay, there we go. So write a function called string op. The function takes 2 arguments. The first argument, the first one is called string, is a string, on which an operation will be performed. The second, called command, can be any variation of the words upper, lower, capitalize. So for example, upper could be spelled in mixed case. So when they say any variation, they mean any casing, any case combination. So this function should return a new string that is the result of the command. If the command isn't valid, return invalid command. Okay, cool. So for this one, def. Let's do this first. Invalid command, and this will actually be in our else. Oops. There we go. So we'll say if, actually first what I want to do is string equals string, nope, not string, I want to do command. Command equals command dot lower. Okay. Command equals command dot lower, and this is exactly what I was talking about. So I lowercased it so I don't have to check every combination of casing, and you'll see what I mean. So if I say if command equals upper, right? And since I lowercased it, I don't have to do something like something ridiculous like, make a tuple to check every. So we've got 2 to the 5th possible casing combinations, which is 32 versions of a 5-letter string that we could do. And then capitalize, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 2 to the 10th possible casings for capitalize, which is 1024. So we obviously we don't want to like write out, some massive thing just to check. We can just standardize the case and say, okay, we'll make command into a lowercase version of itself, and then we'll just check if it's equal to the lowercase version of that command. So if command equals upper, return string dot upper, and we'll just duplicate this, make these elifs. This will be, let's just do this. Lower, capitalize. Cool. All right. So there's that. And let's just test the other ones. So we got upper, lower, capitalize, and let's do an edge case. I'm not going to write in the expectations because they're kind of straightforward. I know the casing is working, so I'm not going to test that either. And foo. So we get an uppercase string, a lowercase string, a capitalized string, and an invalid command. And that's what we wanted to do. Awesome. Replace. Okay. So replace, remember we're talking about strings. This whole section is on string functions and methods, right? So replace is a string method. It sure does sound like it's going to change the value of the string. It sure sounds to me like a mutable, like the name of a mutable method. It's not, though, because strings are immutable. So if I have a string and I want to replace some characters in it, let's just find a string here. I don't have my notes document doesn't have my usual test string to play around with. I haven't reconstructed that yet. Let's just do. I'll just steal this one. So this is an example. Let's do dot lower. Real quick. Just going to do that. This is an example. Okay. Oh, wait. Okay. Sorry. Text equals that. And let's say I want to replace all the i's with something. So if I say text dot replace I with O. How about that? Print text, right? So remember, ask yourself, and I'll give you all a minute for this. Ask yourself, what's the result of text going to be when I print text? And if you get it right, you have a pretty good understanding of mutability. So either it's going to have all the I's replaced with O's or not. So, yep. So this is an example. It prints out and the I's are not replaced with O's, right? So this is what I was saying, right? This sounds like it's a mutable method. It sounds like it's going to change the text, and it can't. No method can do that for a string because strings are immutable. So if I wanted to say, if I wanted it to have the effect of changing it, I'd have to reassign the value of text. Text equals text.replace. So I'm saying there's a chance. I'm not quite sure what you mean by that question. If you're wondering if there's a chance that it would be replaced, no, there's not a chance that this would be. It's not like it may or may not affect the string. It's that either it would or it wouldn't. Those are two behaviors that we could expect, feasible behaviors that you could possibly expect from something like this. And I'm framing that question in that way to kind of get at the, like, what is the behavior given that we know strings are mutable, right? Excuse me, strings are immutable. So yeah, sorry for the confusion there. It's not one maybe it might happen sometimes, the other one might happen sometimes. Since strings are immutable, we can expect that this will not cause a change in the string, and instead what it's going to do is return a different value, and that different value is going to have a different ID, and it's going to have the changes made to it. So the ID means it's literally a different object in your program's memory. So yeah, that's all I meant by that. There's a 50-50 chance okay, I see what you mean. All right, I took that too literally. Okay, cool. Good. All right. Das us an example. All right. Let's see. So just to be clear on this one, replace. We call it on the string. We want to do the replacing n, and then we say what we want to replace, then what we want to replace it with. So I is the target, and then O is the thing to replace the I's with. Somebody's asking if, let's see, let me see if I can get this really quick. Somebody's asking if this will print off the replaced text. Yeah, so this would print off the replaced text, but it wouldn't cause, still it wouldn't cause a change in the value of text, right? So that just prints it off, and then the text still remains unchanged, unless we like deliberately reassign it or something like that. So yes, you are correct. All right. Count argument. Oh, and I forget. This one has like, it's a similar to splits argument, that max split argument, but it's a count. It tells you how many of the thing you want to replace, right? So let's say if I only want to replace the first I can just say 1, right? And then we have THOS and is an example, so that all the other i's are going to remain unchanged. Chaining methods. We can also chain two methods together in Python. This allows us to use multiple method calls on the same object. I wouldn't have put this line here. I would ignore that line. That's a bit misleading, I think. Sometimes this can be the case, but not always. So chaining methods, I remember like when I first started programming and like I would see people chain methods together and it just looked like, often it just looked random and kind of like nonsense, but it made sense to me when I started thinking about what, every time I saw a method or a function call, I think, what does that return, right? So for methods on immutable types, every one that I'm aware of will return something. I don't know why it wouldn't return something. It doesn't make sense why it wouldn't. So I think it's safe to say that any method on an immutable type is going to return something. It's likely that it'll return the same type that it's a member of, right? So a lot of the string methods return strings. Instead of mutating this string, they just return a different version of it. Lower, upper, capitalize, replace. So let's say you have a string method that returns a string. Since that expression returns, it evaluates to a string, you can call another string method on it, right? So I could say text.replace I with O, and then I could say dot upper, right? Because text.replace I with O, this text is a string, but text.replace I with O is also a string. So that evaluates to a string, and I can call a method on it. And then let's say, I guess I could split it, right? So split now returns a list. So that's where things get a little different. So here we have the I's replaced with O's from the replace. Everything's uppercase from the upper, and then we split it into a list like this, right? So if I wanted to, let's say, get the count of dot count OS, right? So it'll say there's one OS in there, right? So now this whole thing evaluates to an integer, and I don't even think I know any integer methods. I don't use them. Let's just look them up real quick. Dear, there's probably one that I'm just like not thinking of for some reason. Oh yeah, to bytes. Sometimes I use this. I've used this. So now I could call an integer method on it. Dot 2 bytes. Oops. Something like that. All right. It takes an argument, which is a length. What's 4? Missing another argument, byte order. This is one of the ones, like, I don't use it often enough to remember. I have to like refigure it every time. So let's do help on 0 dot or int dot to byte. Big. Let's try that. All right, so that's the result of that. Which, oh gosh, that sure does look like a string. I wonder if that's a string. Let's see what the type of it is, right? So, so anyways, I'm kind of okay. I admit it. I've officially got off track here, but so that's bytes. That's a bytes type. It's its own type. The point is, I can make this really long method chain, and it makes sense to me because I'm just thinking, what do each of these evaluate to? I.e., what do they return, right? So text.replace returns a string, so I can call a string method on it. Well, upper is a string method. Upper evaluates to a string. It returns a string, so I can call another string method on it. I'll call split. Split returns a list. Count is a list method, so I chose count because it returns something, returns an integer. So that returns an integer, which I can call to bytes on, and then, et cetera, et cetera. So if you're wondering about when you see those big long methods chains, just think like, what does each section return? Excuse me, get something in my eye. Apologies. Okay, let's just jump into the challenges. What will the result of the following commands be? Okay, replace space with X, capitalize, replace I with uppercase I, lower, so that's just going to lowercase everything. Replace X with space. I think it's, gosh, is that going to be, this string will have, it's going to be a lowercase version of the string. That's it. Yeah. So just in case you didn't follow with that, right? Replace space with capital X, we capitalize. That's going to change those X's to lowercase. It's already capitalized. Notice the first value is capitalized. So the X's are all now lowercase. Replace lowercase I with capital I and then dot lower. So this replace has no effect because we call dot lower on it right afterwards. And then we replace lowercase x with space, which means we take all those x's from the spaces from the first part and just replace them with spaces again. So we end up with where we started, except that this that was capitalized at the beginning is lowercase because of this dot lower here. So the only one that actually had any effect was that dot lower. We got a question about the method chains evaluating from left to right. Yes. Is that the way to think about that? Yeah, so a method chain would evaluate from left to right. There's a little bit of a caveat there because, well, okay. Let's look at this, right? Let's say after this split, the split gives me a list. I could dot join right, and so dot join is a string method, but it's not part of that chain. And the way that this would evaluate is left to right, excuse me, inner to outer, left to right. Inner, yeah, so inner terms first, each inner term from left to right, outer term left to right, outer term left to right. So in this case, join would be the last thing to evaluate for whatever that's worth, even though it's on the left. And hopefully this is clear. join is not part of, like, we don't consider join to be part of that method chain. It's just, it's its own method. It's not chained together. Like, this is an argument. This big weird method chain is an argument to join. It happens that I can pass it as an argument because split returns a list of strings, and join takes a list of strings to be joined. So, anyways. All right. So remove vowels. Is that all I'm doing? Complete the function, remove vowels. This function takes a string object as a parameter. Remove the vowels from the string. For this function y, it was not considered a vowel. Okay, cool. I'm going to accumulate onto the parameter here. I'm just going to say for v in a e I o u a e I o u string equals string dot replace v with empty string and then return string. Let's see if that works. Okay, that does it. So, quick note here. It's kind of bringing things back to mutability again. If this were a list, or I mean, if it were any mutable type, we'd want to do something like string equals string dot copy, or like string copy, whatever, something like that, and then use that copy. But we don't need to do that because it's an immutable type. So the reason to do the copy thing is when you call it, okay, so we'll just do this. So if this were a mutable type, which it's not, we would have to worry about the function possibly changing the variable, right? Which it's not going to do. So notice, let me comment this out. So notice we get hello world printed out with the vowels removed, but it didn't affect our variable. And this is a feature of immutability, that when we pass an immutable object to a function, the function isn't able at all internally to alter the object because it's immutable. We can play around with the pointer to the object, right? The pointer is an identifier called string, and we can make reassignments to that identifier, but that's different than altering the object, right? So this is safe, right? We don't need to make a copy. There is no copy method for a string anyways, because there's no point. There's no reason to have one. Every time you do anything that changes a string, by definition, since it's immutable, you get an object that has a different value and a different ID and is therefore a different object, right? So you can do these transforms that gives you different objects. Maybe you could reassign to the identifier that was pointing at the old object, and it kind of seems like mutability, but it isn't. So there's that safety with immutable types, like that. That's why I can do it that way. Okay, replace doubles. Okay, cool. Quick reminder: if anybody's got any questions, please feel free to put them in. That's really the main point of study halls. I mean, I like going through materials, and I think some folks find it useful as well. So if you're enjoying just watching the materials, that's cool too. But yeah, I mean, definitely feel free to bring in your questions. Um, don't be shy. You wouldn't be interrupting me if you just put in a question in the middle of this. I'll just find a good place to stop and take your question. Cool. So write a function called replace doubles. Okay. I get questions about this one pretty frequently. I'm trying to think of words that have double letters. Foo. Shmoo. Okay. Cool. So what we want to do is replace the double letters with single letters, which will give us hello, bro, foo, and shmoo. Okay. So def replace doubles takes in string, call it text, and I'm just going to iterate through for C in text. Text. And again, I'm accumulating directly on the object that I'm taking in. Well, not on the object, on the identifier, on the parameter name. So text equals text dot replace C times 2, so that's double C with single C. And then return text. Cool. So that's all we need for that one. So I think the trick with this one is, just this line here, this double C with replace double C with single C is kind of a nice little trick. And then this just will replace any double occurrences, right? So it's going to go, it's going to try to replace all double H's with single H, then all double E's with single E, then all double L's with single L, and there actually is a double L, so it's funny is by the time it gets to this O here, it's already replaced these double O's, right? So yeah. Pretty nice and simple function. And this one's going through the whole alphabet, upper and lower case characters, iterating through that, and then replacing, same thing, replacing double letter with single letter. It's just iterating through something different. Formatting, all right. So create strings with dynamic values using the stir.format method, dynamic values with the f string. Okay, so let's look at the dot format method. So format strings are really nice because imagine we have some information that we want to include in a string, but we don't know what it is at the time writing the program. And maybe it's a number or something, So we can use format strings to template in that information as our program is running into the string. So if I say, let's just do something like for I in range 2 to 20. And then we'll say print, and I'm going to make an f string, and I'll say we'll say the square root of I is I to the half. Okay, which is the square root of I. And notice it doesn't show me the curly brackets. It shows me the actual value of I and the square root of I. Of course, I could break this out. I could break this out into a variable or whatever, right? I don't have to put the math in right there, but yeah, I could if I wanted to. So this will, actually print out the square root of 2 is 1.4 whatever, the square root of 3, the square root of 4, etc. So yeah, so what's happening here, this is called an f string. You might be able to guess why, because it just starts with an f. I just put this f in front of the string, and that's going to make it into a format string. If I take that f off, it's going to literally just print the curly brackets with I, right? It's just going to print this string literal just exactly as you see it. If I do the f in front of it, it's going to have the values inside the curly brackets. If I wanted to actually literally type a curly bracket in an f string for whatever reason, I would have to use an escape character like this. We'll just do that. Oh, is it not even going to let me do that? Single curly brackets are not allowed? Oh, okay. Well, that's okay. I guess you're just supposed to use double curlies. Okay, so the double curly brackets will literally put in a curly bracket, and the single will be treated as an actual template point. So the f string is syntactic sugar to the dot format method. And dot format, so if we do it this way, then we leave the we'll leave the curly brackets empty, and we'll pass in the things we want templated in, formatted in, excuse me. We'll pass in the things we want formatted in as arguments into the dot format method. I prefer to use f strings. I believe Tovio prefers to use the dot format method. You do you. but just so you know, whichever one you see out there, because you will see both, they are essentially the same. So when I say essentially the same, I should be clear. They are exactly the same. Exactly the same thing is happening, even if they look a little different in the code. Okay. Cool. Let's just jump into the challenges. Is this going to get into... yes. Okay. So what is the proper way to insert the value of pi into a string so the result of pi is 3.14? We could do... this one. Oh, 3.14, right. So I forget about this. There's additional formatting options that you can include in f strings. So we have this colon dot 2f. I think this one would do it. I kind of don't use these formatting features that often, so I forget about them, but I need to kind of go look them up every time I need them. I really should, though. I should just like make a cheat sheet and commit those to memory because they're extremely useful. So, all right. Returns the string my favorite numbers. My favorite numbers are x and y. So I'm just literally going to do this. I'm just going to copy that. Return this, and we'll do curlies there. Oops. And we'll make that an f string. Bingo. Okay, so this is going to return whether x is greater than y. And I'm just going to do return f. This will be, I'm just going to do max of x comma y is greater than min x comma y. And their difference is, well, let's do this. We'll do larger, smaller. And we'll say larger minus smaller. Whoops. Let's see if that'll do it. Okay, I probably missed an edge case or something. Okay, so that's interesting. Because 3 minus -6, well, that should be... Huh. Well, that's very interesting. We have to do some trickery there. 3 minus -6. Alright, fine. I'm interested. I hate the not wrapping over. Let me see. I really gotta just fix this. Soft wrap. Please. Work. Yes. Okay, that's gonna wrap over now. Good. Okay, so we have to fix this difference thing, because if I call this one, pretty sure I'm not going to get that. Okay. It says their difference is 0. So that's really interesting. This is saying 3 minus -6 is 9. Okay. That's peculiar. All right. Their difference is 0. Maybe if I do diff equals this. Let's try that. That's still going to be the same. Does this need to be in parentheses or something? Wow, that's really peculiar. 3 is greater than... Oh my gosh. I'm so silly. I forgot to change... I just forgot to change max to min. Yeah, okay, that's what I thought. Alright, so... I got punished for copying this when I should have just typed it back out. Okay, so I just didn't change... I didn't change smaller to min of x and y, and I didn't read my output all the way. Okay. That's on me. There we go. That should work. What? What are these shenanigans? Oh, I forgot the period, it looks like. Is that what I'm missing? Really? Will this work too? The absolute value of x minus y? I think it will, yes. But this... Initially that's what I was thinking. Maybe I'm going to have to use the absolute value. But this actually does, just subtracting the larger from the smaller does give us 9, which it should. But I think we'd only get a negative difference if we subtract a smaller number, or a larger number from a smaller number. So yeah, the order should give us the correct answer here. So yeah, it's just that thing about min. Okay, cool. And then I remembered the period, and that made it work. tuples. Okay. We got about 10 minutes left. I'll put in a last call for questions. I'm not seeing any. I'm assuming everybody's good and just, hanging out, chilling, watching the material, so I think we're good. We're starting a new section here, so I don't want to get too far into it, but yeah, so we're going to be talking about tuples, it looks like. I think there can be some confusion around tuples. Like, we teach them after lists, and they kind of seem like weak lists. Like, why would you use tuples if you have lists? And I think most people will, if given a choice, will default to a list. And there's an argument for doing that, I guess, but tuples are really great. You can think about them. This isn't on a lower level. This is a little reductive, but you can think about them as a list that is immutable. So it's a list without any of the mutable features of a list. Other than that, it's the things it has in common with a list is that they're both ordered, indexed collections of arbitrary objects. Arbitrary just means it can be any old object. They can hold immutable types or mutable types, whatever. You can put whatever you want in a tuple. Another cut below that, the way they work on a little bit of more of a mechanical level is lists literally encapsulate the objects that they hold. Lists truly hold their objects. And what I mean by this is that in your RAM, we'll just pretend that these are a bunch of RAM addresses. These are not consistent size. That bothers me. Right, so these are just RAM addresses, and like we can imagine this being like hexadecimal, whatever, hexadecimal values in each of these addresses, whatever. So we can imagine our list starting here, right? So whatever this address is says a list starts here. And there's probably like a header for the list that describes something about what it is, and it's ignored as not the first element. I'm not exactly sure on how Python lists work on that level, but I believe they do have some kind of information in the first byte or so. But then from there, oops, this is going to be object 1, or let's call it object 0. Object 1, 2, 3, 4. And then this byte will represent the end of the list. Right, so the memory, the way that your memory is structured when you have a list, it is literally like this. The list literally encompasses these objects. A tuple doesn't contain objects, technically. A tuple will contain a pointer. A pointer to some other object somewhere else in the memory. So a tuple just contains the addresses of the values that it quote unquote holds, right? I'm not going to get into how that's important here because we're already kind of diving pretty deep into this. Someday it's likely that this information will come in handy, and now I've planted it in the back of your subconscious. So when this does become useful, you'll be able to have some basis of understanding what that means. But yeah, so under the hood, lists literally contain the objects, and tuples just contain the pointers to the objects. So that's let's call that a mechanical difference. The practical difference is that tuples are immutable lists. So if you have a list and you're like, well, I sure wish this was immutable, then, well, have I got the data type for you? Yeah, they're pretty great. I will tend to, if I can get away with it, I will tend to use tuples over lists because there's not much. Most of the mutable operations in a list can be emulated with tuple transforms, slicing, concatenation, and indexing. So you can use the plus operator to concatenate two tuples together. You can slice and index into tuples like you can with lists. You can't do item reassignment like you can with lists, although you can kind of emulate it with slicing, concatenation, and indexing. So I remember those three: CSI, concatenation, slicing, and indexing. CSI Miami. That's the mnemonic that I use. Judge me as you will. Okay. So let's see. Well, shoot, that puts us pretty close to time. Yeah, I guess I'll leave it there. We'll get more into tuples next time. We got a comment here. I get confused about tuples. I don't recall the differences from lists or their use cases. Yeah. Well, I guess hopefully I kind of went over that a little bit. I'll give a quick example here. Let's say I have list equals A, B, C, and then print my function takes in list, and we'll print list. If I do def my function, take in the list, and we can say list plus equals a list of ABCD, and then we'll return list. Let's check this out. Okay, so I returned the list with D on it, but I also mutated the type internally. This is an anti-pattern, And this is a really small, kind of toy, useless example of something that you want to avoid, but if you're taking in a list or a dictionary or a mutable type and you intend to make any alteration to it at all, you should copy it. So what this should be is like list equals list dot copy, something like that, and then now I'll return a copy. If this were a tuple, I'm not gonna rename it. I should have called it array or something so it's have a more generic sounding name, but if this is a tuple and I need to do a single element tuple like this, it's a little bit silly, but so I don't need to copy a tuple. So I prefer this behavior. I prefer immutable. I prefer to use an immutable object everywhere that I can, because in general I don't have to worry about it as much. I don't have to like worry about accidentally changing something somewhere where I didn't intend that change to occur. If something does change, it's as a direct result of code that I wrote, right? So if it's happening in a way that I didn't expect, I can't blame the interpreter for behaving in unforeseeable ways. I can only blame myself for writing code that's doing something that I somehow, even though I wrote it, didn't expect to do, right? So, if there's a problem, at least I know I caused it. You know what I mean? If there's a problem, I can isolate where it is more. More often, though, if you get used to working with immutable types and kind of leaning towards immutable behavior over mutable behavior, you just get used to it and you just don't encounter as many weird issues. And of course, you can, it's not that mutable types are bad or that you should avoid them. Mutability is necessary and very useful in computing. But it can be, it's with power comes responsibility is what it is. So mutability gives you the power of mutability, but it also comes with the responsibility of managing that. Whether or not in this example, I'm doing this example with a list or tuple, doesn't matter because it's such a tiny scale. But on a massive scale, there are a lot of standards for really large scale, infrastructural things across servers and, big, large software projects where it becomes really important for the sake of maintainability to enforce or to insist that new classes be written as immutable classes, because if you don't do that, then all bets are off. You could cause a change somewhere that has effect after effect, kind of a chain reaction. So, yeah. So that's in terms of an example, a use case difference example. That would be kind of a small scale example of why mutability, of an advantage that immutability has over mutability. Even though it's technically less powerful, it's kind of easier to deal with, and there's kind of a lot of power to that, especially at scale. So, yeah, we'll talk more about that later next class. All right, I'll wrap it up there. Thanks to everybody who hung out and asked questions. Please let me know how the streaming is, if the video quality is good, if it's bad, if the audio, whatever, any little thing, let me know, because I'm just getting, this is my first stream on my new computer, so I think there's some kinks that I need to iron out a little bit. I know there might be a hum in the background with the mic, and I haven't isolated that one yet, but hopefully that doesn't have to persist. Yeah, cool. Yeah, thanks again. Go ahead and leave a thumbs up on the video if you liked it, or not if you didn't. That's fine too. And feel free to DM me. I'll get back to you as soon as possible. And you all have a good rest of your day. I'll see you for next study hall on Friday. Cool. Bye-bye.